Concerning the extra problem, so this is gonna be kind of your first homework. Let's do the example. So I need to define first how to calculate the scrap rate, saying if you need here 100 units, okay, but you're getting into the system, for example, 1000 units, and for whatever reason 90% of the unit are scrap, damaged, and 10% are acceptable or is acceptable of the unit, so the remaining is 100. If we consider this 100 as y amount and the 1000 as x, so y equal x times, we have the scrap, for example, is 90%, so 1 minus the scrap percentage, so 1 minus 0.9, that's 90% scrap. So let's assume exercise 1 that you need to produce and ship 1000 units of products from the plant in an 8-hour shift, 30 minutes for lunch, break, 8 minutes for team meeting, allocated or assigned. Let's assume there is a 90% efficiency. Calculate the standard time. The time in minute needed to produce a certain amount of unit, usually 1 unit. Okay, so here the question is what's supposed to be the standard time, okay, roughly, in order to produce 1000 units in the remaining time per day available. Okay, consider 90% efficiency as scrap. Okay, as a second example, for example, if you have 1000 units to start with and you have this sequence as A, B, C, D, E, B, F. So the normal sequence is A, B, C, D, E, A, B, C, D, E, B, and F. Okay, so this is the starting, this is the ending. What if we starting with 1000 units and you have the scrap rate at each one of them? So those are the damaged one. Here is 0.02, which is 2%. And here, for example, is 0.05, 0.04, 0.1, 10%. So this is the first question, how many you expect to be delivered at the end. And if this BCDEB is repeated twice, like BCDEB, BCDEB, and F. If it's repeated twice, what do you expect it to happen? As BCDEB, BCDEB repeat twice. Okay. One way of doing it, just say before F and after F. After F is, we need to calculate before F. Okay? And then go all the way backward. Given a 10-hour shift, I will give you an example. The amount of unit here after A, just call it A double prime, and A prime is before A double prime after A. It is equal to A prime times 1 minus 0.02. Deal. B double prime, A double prime is similar to B prime. B double prime after B, so it will be A double prime or A prime times 1 minus 0.02 times 1 minus 0.03, all the way to the end. Question 3. Given 10-hour shift, if a total 10 minutes allowed for break and 10 minutes clean up is given at the end of the shift, determine the takt time. Takt time is similar to the cycle time or the standard time. Assume 80% efficiency on scrap. Again, during the shift, you need to build this amount of unit. 3 operations are performed on a part of this operation and 1 3.5 0.5% scrap respectively. Determine the number of planks required to produce 5000 units. 1 million units of a certain product are to be manufactured annually on dedicated production machines that run 24 hours a day, 5 days a week, 50 weeks per year. If the cycle time of machine to produce one part is 1 minute, how many of the dedicated machine will be required to keep up with the demand? Assume the worker efficiency is 100%, no scrap. Solve part A, except that availability now is 0.9 time availability. Okay.